All right. Hello, everyone. Kindly confirm if you can hear me. Can react to the thumbs up. Okay, cool. Thank you so much. So welcome to this meeting. Today we are going to learn how to explore data using Pandas, NumPy, and Jupyter Notebooks. So I'm going to assume that this is mostly a new concept for all of us. So it's going to be mostly elementary content. That is, it's going to be the basics of everything. So basics of NumPy Pandas, nothing too crazy, nothing too complex. I don't know whether I should make this a series. It will depend on my time. But if so, if you guys think this session goes well, then I think we can make this a series and learn some Python together. But as of now, we can start with exploratory data analysis. So as you might have seen in the poster, it was at least a prerequisite that you know a little bit of Python, because NumPy and Pandas and Matplotlib are packages that are built on top of Python. So it would be great if you already know a thing or two in Python. At least you know what a function is, how it works, things like loops, variables, how to execute a line or a program. Yeah, and just working in an IDE or a not text, but code editor. So yeah, I think without further ado, we can begin. Let me just share my screen. Okay, so some ground rules as well. If you're not speaking, just kindly mute your mic to avoid disturbances throughout the session. Again, kindly confirm if you can see my screen.
Sure, we can see your screen.
Awesome. So today's session essentially will, as you can see on my screen, will be coming from something called Microsoft Learn. So hi to the people who are just joining, kindly mute your mics so that we don't disturb the rest, kindly. Okay. So as I was saying, today's content is coming from Microsoft Learn. So Microsoft Learn is a great website if you want to, as it is suggested in the name, to learn things, especially anything with regards to tech. Really, you can find anything and everything there. It has documentations, it has tutorials, it has videos. So it's a really great website. I'll share the link to this specific module that you're going to look at today in the chat. Let me just do so right now, so that if you want to follow along, you can do so at your own pace. Although we will get technical in a bit and jump into some code. So I also hope you're firing up your code editors in the background so that we can work together. So I was just sharing the link to the Microsoft Learn module. Sorry, I'm getting a notification or a chat that my voice is breaking. Is this the case for everyone, or is it just John who's experiencing this?
I think it is maybe on his side, but I personally, my side, your voice is very clear.
Okay, thank you for the confirmation. So maybe John, you can check on your net. In the meantime, I think we can begin. So my name is Gregory Opondi. By the way, I didn't introduce myself. My name is Gregory Opondi, fourth year economics and statistics student at the University of Nairobi. And I'm also a Microsoft Learn student ambassador. So without further ado, let's jump right into the session. Also, I'd like to request, I don't know if there's any student ambassador in the meeting. If so, kindly help me admitting people, because once I'm sharing my screen, I cannot see the people who are attempting to join. Okay, so that's enough. I believe we can begin. One last thing, kindly mute your mic if you aren't speaking, to those who are just joining. Okay, so as I said, we're going to explore and analyze data with Python. We're being told that data exploration and analysis is at the core of data science, and data scientists require skills in programming languages such as Python to explore, visualize, and manipulate data. That's why I was saying you should at least have the basics of Python so that you can benefit from this program. So in this module, we learn how to uh, explore data. So we're going to learn the common data exploration techniques. We'll also learn how to use Python packages like NumPy, Pandas, and Matplotlib to analyze the data. So, as I said, the prerequisites, they were also in that poster that I shared. You should have like some basic knowledge in mathematics. So it's not something very complex. Like you should just know like basic arithmetic, that's addition, subtraction. You should know what mean is and things like that. So you should also have some experience in Python. I think we've stressed this enough. Last but not least, you should have some familiarity with Jupyter Notebooks. Although I'll give a few clarifications when it comes to Jupyter Notebooks. So let's begin with the first module. Again, they're just stressing that the role of a data scientist involves exploring and analyzing data. Although the end result of data analysis might be a report or a machine learning model, depending on why you're doing the data analysis in the first place, data scientists begin their work with data, with Python being the most popular programming language that data scientists use to work with data. So after decades of open source development, so that's Python, which is an open source program, meaning people contribute to it, like the community contributes to it, so it's essentially free. Python provides an extensive functionality with powerful statistical and numerical libraries. So we have NumPy and Pandas, which simplify analyzing and manipulating data, as we are going to see in a bit. We also have Matplotlib, which provides attractive data visualizations. Scikit-learn, which offers simple and effective predictive data analysis, and also TensorFlow and PyTorch, which supply machine learning and deep learning capabilities. But for today's session, we'll strictly focus on NumPy, Pandas, and Matplotlib. So we have this case scenario that we're going to be looking at today, which is suppose that you are a university professor and you collect data about your students, including the number of lectures they attend, the hours they spend studying, and the final grade they achieve at the end of the exam. And you want to verify whether there's a relationship between the amount of studying that a student undertakes and the final grade they achieve. So you want to essentially check how much time does each student spend studying, let's say per week, how many hours do they contribute to studying? And then after that, you look at the final grade, and then you want to check, is there a correlation between the amount of time spent studying and the final grade that a student gets? So the professor might use the data to test a hypothesis that only students who study for a minimum number of hours can expect to achieve passing a grade. So uh, just juggling between two screens, trying to admit people and also sharing the content. So
I have a question. Sorry for the interruption.
It's okay.
Where are we
Go
getting
ahead.
this material from? Where are we getting the material that you're using?
Oh, I had posted a link. Let me just repost it in the chat.
Thank you.
It's okay. All right, so it's in the chat. You can just click on the link and follow along.
Thank you.
All right, moving along. I was saying that the professor might use this data to test a hypothesis. And so essentially a hypothesis is just a claim or a proposition that can be tested using data that can be tested statistically. So in this case, the professor is making a claim that the students who study for a minimum number of hours can expect to achieve a passing grade. So the professor might say, let's say the minimum hours is 5 hours per week or something like that. So by saying if you study 5 hours per week, you can expect to achieve a passing grade, which is, let's say, 60%. So that is what a hypothesis is, and that is what we're going to be doing today. We're going to essentially try to use data to solve the hypothesis that the professor was making. So, as I said, in this training module, we'll explore and analyze grade data for a fictitious university class from a professor's point of view. We'll use Jupyter Notebooks and several Python tools, so that is NumPy, Pandas, and Matplotlib, um, to clean the data set and apply statistical techniques to test several hypotheses about the data, and then we'll visualize the data. So let me just admit more people. Okay. All right. So as we said, data scientists use several tools and techniques to explore and visualize data. And then one of the most common ways data scientists work with data is to use Python language, and essentially not just Python by itself, but the packages that have been built on top of Python, such as the first one is NumPy. So NumPy is actually short for numeric Python. So as you can tell from the name, it just helps you work with Python, but in a numeric way. They're saying that NumPy is a Python library that provides functionality comparable to mathematical tools such as MATLAB and R. Personally, I haven't used both of them, so I can't explain the comparisons between NumPy and MATLAB. However, I've used NumPy by itself, and I can tell that it is a numeric way of analyzing data in Python. So while NumPy significantly simplifies the user experience, it also offers comprehensive mathematical functions, which you're going to see. And then Pandas. Pandas is an extremely popular Python library for data analysis and manipulation. Pandas is like a spreadsheet application for Python, providing easy to use uh, functionality for data tables. So essentially, Pandas helps you display data like this, like a spreadsheet. So if you've worked with Excel before, you know, like this is how data usually looks like when you key it into Excel. So Pandas also helps you explore a similar interface, but on Python. Okay, so let's continue. And then also, as I said, we're going to use a Jupyter Notebook. So as opposed to just writing your code in a normal Python script, we're going to write it in a Jupyter Notebook. So this is going to help us both write the code and document it. So as they say, Jupyter Notebooks are a popular way of running basic scripts using your web browser. Okay, so when you download Jupyter Notebooks, by itself or using Anaconda, mostly it runs on the browser. But personally, I didn't use that method to install Jupyter Notebooks. I installed Jupyter Notebooks via the VS Code extension. So I use VS Code to write my code, and I downloaded the Jupyter Notebook extension. So having the extension, I'm able to run the Jupyter Notebook not necessarily on the browser, but on VS Code by itself, which is my preferred code editor. So typically these notebooks are a single web page broken up into sections and code sections that are executed on the server rather than your local machine. So in my case, since it's on VS Code, it is executed on my local machine. But if you are using a notebook that is online, for example, like even in this module, in the link I've shared, there's a notebook that is online that won't be executed on your local machine. By running code in Jupyter Notebooks on a server, you can get started quickly without needing to install Python or other tools. So if you don't have Python installed or you're on a device that doesn't have Python installed, then you can go ahead and use the link I've posted in the chat to access this website, and then you'll find Jupyter Notebook, which is on the next module. But since I did it locally, I would like to share my work on my local machine. So as from here, we are going to be hands-on. Essentially, we're just going to be on our code editors. So advise you to power up yours as well. Open up a notebook so that we may begin. Again, kindly confirm if you can see the new screen that I'm sharing.
Yeah, we can see a screen.
Cool. Thank you so much. So let's proceed. Just hide this for a bigger view. So we're going to explore data with Python, as we've said a lot. We've already talked about how it is a data scientist's role to explore and visualize data. So I said we'll talk about Jupyter Notebooks, but very briefly. So if you've never used Jupyter Notebooks before, here are a few things which you should be aware or which you should know essentially. First of all, the notebook is made up of cells, and there are two types of cells. So the one you're seeing currently is what we call a markdown cell, where you just write text in markdown format. So markdown format essentially helps you to just, let's say, write headings, notes, and things like that. And then there's a code cell, which now looks like this, where you write your code and you execute it. What else? You can run each code by using the triangle of the play button. So essentially next to every code cell, when you hover above it, there's a little triangle or a play button there where you can use to run your code. The output of each code cell should be displayed immediately below the cell. So we'll be seeing this throughout. And finally, even though you can run code cells individually, so that's one by one, the code uses global. The code uses are global to the notebook. So what that means is, when I run code here and I store a variable, so in this case we see there's a variable called data. This variable called data, once I run this cell, will be globally accessible to the rest of these cells. So I can write code in any other cell accessing the variables that I've initiated up here in the first cells. So now we can begin now that we've understood how Jupyter Notebooks work. So the first thing we're going to explore is NumPy. First of all, we're going to explore the basics of NumPy before we move on to Pandas and finally Matplotlib. So right now we're just going to look at simple data before we go into the data that the professor collected. So some simple data is, suppose a college professor takes a sample of grades. So these are just grades, and they are stored in a data set, in a variable called data, right? So someone got 50, 50, and this variable is actually a list. As you can see, it's in the form of a list. So we can print it to see how it looks like and the type or the data type. So we see that, okay, we've printed the data and then it's a list, as we said. So the data has been loaded into a Python list structure, which I said it's good for general data manipulation, but it's not optimized for numeric analysis. For that reason, we are going to use NumPy, which has specific data types and functions for working with numbers in Python. Just admit a few more people. Okay. So we're going to use NumPy essentially to try and see or analyze this small data set before we move on to a slightly larger one, but not a crazy large, still small. So we can run the following cell to load the data into a NumPy array. So we have now a new variable called grades, and we run the function np.array and then into brackets data. So the first thing we did actually is to import NumPy, which is the package that we are talking about that helps us analyze data in Python. And we import it and give it the alias np because we don't want to keep on typing NumPy, np is shorter. So anytime you see np dot something, just know we are accessing the functionalities of NumPy. So here we have the variable grades, and then we assign it the value of data, which was our list. But then this data, we are running a method from NumPy to turn it from just a list to what we call a NumPy array. So now when we run this new code cell, you can see now, even just by looking at it, there's a difference between this and this. The biggest difference that you can observe is that this has commas and this doesn't have commas. And I think I can even go a step further to print the type again. So I'm going to add a new line so that the code is just cleaner, or the output is cleaner. And then now I'm going to print the type of grades. So as you can see, it's a NumPy, and then it says here ND array. So the ND here is short for n-dimensional array, meaning that okay, how do I explain this? It's an array that can be in many dimensions, in n dimensions essentially. So in this case, it's just a one-dimension array or a one-dimensional array, but you can also have two-dimensional arrays, three-dimensional arrays, and so on and so forth. But mostly people just work with one and two-dimensional arrays. Okay, continuing. So just in case you were wondering about the difference between a list and a NumPy array, let's compare how these data types behave when you use them in an expression that multiplies them by 2. Yes. So we have 3 lines of code. So the first line of code is print. There shouldn't be a space here. This will bring an error for both of them actually. So the first line here is print, and then inside the print, so what we're going to see once we print is, first of all, the type of data, which we said is list. And then, so we're going to write list times 2, because this is a string. So it's going to print list times 2, just telling you that we are printing this list times 2. And then now we're going to observe how does it behave when we print it or when we multiply it by 2. Then again, just added a line here so that you can clearly see the output without any confusion, just like separating the output between the list and the NumPy array. So the second line again, here now the type of grades, as we've even seen here, I added it here, the type of grades will be NumPy array. So here it's going to be nd.array, no, NumPy.nd array times 2. So essentially it's just telling you the array times 2. And then now we're going to see how it's also going to behave when we multiply the NumPy array by 2. So let's just run this code and see how a list behaves when you multiply it by 2, and then how a NumPy array behaves when we multiply it by 2. So here we see list. When we multiply it by 2, we have our original list that started from it was like 50, 50, 47, all the way to 64, right? It had like 21 elements, but this one looks like it's way larger, right? So it's 50, 50 again, goes again, all the way up to 64. And then we see from here, it's starting again. So what is happening here is that when you multiply the list by 2, it's like it's concatenating. That is, it's just smooshing them together into one big list. So it's taken the list twice and then it just smooshes them together into one big list. So our original list had like 21 elements. You can just confirm by running print len data. Yeah. Yeah, it had 22 elements. So this one now has 22 times 2, which is 44 elements. However, when it comes to the NumPy array, we see that when we do times 2, instead of just smooshing the arrays together the way the list did, instead of just concatenating them, NumPy actually takes these 2 and multiplies it against each element. So we see 50 times 50 gives us 100, 50 times 50 again, I mean times 2, 100, 47 times 2, 94, 49 times 2, 98, and so on and so on. So we see that a NumPy array has benefits over the list in that a NumPy array can carry out element-wise operations, whereas a list cannot. A list just concatenates things, right? So you cannot carry out data analysis effectively with a list. You cannot carry out mathematical operations with a list. However, with a NumPy array, this is made possible. So note that multiplying a list by 2 creates a new list that is twice the length with the original sequence of lists repeated. Multiplying a NumPy array, on the other hand, performs an element-wise calculation in which the array behaves like a vector or a matrix. So we end up with an array of the same size in which each element has been multiplied by 2. So the key takeaway from this is that NumPy arrays are specifically designed to support mathematical operations on numeric data, which makes them more useful and more powerful for data analysis than a generic normal list. So you might have spotted the class type preceding NumPy array is NumPy.nd array. The nd indicates that this is a structure that can host multiple dimensions, as I said earlier. It can have n dimensions. Our specific instance has a single dimension, so it's a one-dimensional array. However, we can have two-dimensional, three-dimensional, and so on and so forth. It gets confusing past 2, so most people usually stick to two-dimensional arrays. So let's run the following cell to view the shape of the array. So as you can see, it's grades.shape. There is no bracket after that, meaning that remember, grades is a NumPy array. So when we run grades.shape, it's like an attribute. We're looking at the attribute of grades. In this case, the shape attribute. So by running grades.shape, we see it's 22, comma, and then there's nothing else. So it confirms, yes, there are 22 elements, but then the comma, there's supposed to be something here, but there's not, meaning that it's only one-dimensional. So there are only 22 elements in a row, as you can see here. If there was something else, then it would have been row now and then column. So if it was a two-dimensional array now having rows and columns, you would have seen, let's say it's 22 this way, and then the number of columns as well. So in this case, it's just 22. The shape confirms that this array has only one dimension, which contains 22 elements. So there are 22 grades in the original list. You can access the individual elements in the array by the zero-based ordinal position or zero-based indexes. Okay, there's no one else to admit. So again, if you're familiar with Python, you're familiar with zero-based indexing, meaning we start counting from 0 and not from 1. So essentially, if I come back here, this is element 0, and then now this would be element 1. So NumPy arrays also support indexing, and not just indexing, but zero-based indexing. So we can access the first element by running grades and then in square brackets 0, because that's how we index iterables. So yeah, grades 0 gives us 50. So 50 is the first attribute. Okay. Moving forward. Now that you know how a NumPy array looks like and how it works, it's time to perform some analysis on the grades data. So something else or something good about NumPy, it also comes with useful methods such as mean or .mean. Essentially just returns the mean of your array. So you can apply aggregations across the elements in the array. It also has others like standard deviation and things like that. Let's just do mean for now. So we see that the mean grade that students got is 49.18 recurring. So it's just about 50, which is more or less in the middle of the possible range from 0 to 100, assuming that that is the system they're using to grade from 0 to 100. So let's add a second set of data for the same students. This time we'll record the typical number of hours per week they devoted to studying. So remember, initially our main goal was to check, is there a correlation between the number of hours somebody studies and the final grade that they get. So we can look at this now by adding the study hours. So we've already looked at the grades and we've turned grades into a NumPy array. Let's look at the study hours, which was defined here as a list as well. But then now we are moving forward to create a two-dimensional array. Remember that the grades was just a one-dimensional array. So to create a two-dimensional array, again, we initialized a variable called student data, and inside the variable, we assigned the value NumPy.array, which is just turning whatever is inside here into an array. And what is inside here is actually a list. So as you can see, this part that I've highlighted is a list. And then what is inside the list? Well, the first element of the list is study hours, which is another list, right? And then the second element is grades, which was a NumPy array, as you can see here when I hover over it. So it's going to turn the whole thing into a NumPy array, and it's going to be an array of arrays, if I may say so. So let's display this. So as you can see, it's an array of arrays, where the first array is the student hours, which is this part up to here. And then the second array is the grades, which is from this part to here. So now this becomes a two-dimensional array where we have the study hours and the grades. So now the data consists of a two-dimensional array, an array of arrays, as I said. So let's look at its shape. Again, we looked at the shape of the grades. We saw that it was just a one-dimensional array with 22 elements. Let's look at the shape of the two-dimensional arrays. So now we see it's 2, 2. Remember the first one was just 22, but this one is 2, 22. So this 2 is showing us that they're like 2 rows now, or 2 arrays, or 2 dimensions. And both of them have 22 elements. So it's just like the shape of the student data, or like how it looks like. So the student data contains 2 elements, which is the study hours, which is this one, and the grades, which is this one. So it just contains 2 elements, but then the elements are also arrays, each of which is an array containing 22 elements. And that's what this tuple here tells us. So to navigate this structure, you need to specify the position of each element in the hierarchy. So to find the first value of the first array. In this case, what's the first value of the first array? Well, the first array is this one. And so the first value would be 10.0 essentially. It's just not displaying the zeros, but this would be 10.0. So you'd have to index the two-dimensional array twice. So first of all, you do student data and then you index 0. So by indexing 0, you get the first element of the student data, which is this part, which is another array. And then now you index it again with another 0, and then we get 10.0. So that's why we're having it twice, and we get 10.0. So now you have a multi-dimensional array containing both students' study time and grade information, which you can use to compare study time to a student's grade. So let's look at the average study time. So that's the average study time for each student, and then the average grade, which we already got. And then now I'm just using what we call an F string here. I'm just adding F so that I'm able to print out the variables that are here within a string, that is. That's why it's called an F string. So when I run this, we see that the average study hour is 10.5227 recurring, and then the average grade is 49. So we're seeing that mostly students study for 5 hours. Let's say this, okay, 10 hours, sorry, not 5, 10 hours. Let's say this was per week. So let's say students averagely study for 10 hours per week. And by studying 10 hours per week, you get an average grade of 49.1818. So now we're going to move ahead from just NumPy and explore tabular data with pandas. For that, let me see this and put the lobby, not it. Okay, just a minute. Okay, sorry for that. As I was saying, now we'll continue by exploring tabular data with pandas. So NumPy provides a lot of functionality and tools you need to work with numbers. As you've seen, you're able to carry out element-wise operations, something that you can't even do with lists. So such as array of numeric values. However, when you start to deal with two-dimensional tables of data, the pandas package offers a more convenient structure to work with. So as you've seen, as we go into two-dimensional data, it starts looking a bit confusing. And so that's where pandas comes in. Pandas has a more convenient data structure, which is the data frame, to help us essentially visualize our two-dimensional array of data and work with it efficiently. So let's run the following cell to import pandas and then to create a data frame, a pandas data frame. So we're going to import pandas. Again, if you don't have pandas, you'll have to install it first so that you can import it. Yeah, so you'll run pip install pandas and then it will install. The same goes for NumPy. If you didn't have NumPy, make sure you run pip install NumPy first before you're able to import NumPy. So in this case, now we're working with pandas. So first of all, you have to import pandas, and just like NumPy, we give it an alias PD so that you don't keep on writing pandas, pandas, pandas. You can just write PD instead. And then we start by creating a data frame, which we call df students. So df here just stands for data frame. And so we're creating a data frame of students. And how we are going to do this is, so essentially, I got the data which the professor was using, and it came as a CSV file, right? Which is this, and this is how a CSV file looks like. So CSV stands for comma separated values. So as you can see, the values are comma separated, hence the name CSV. So the first row, we have name, student hours, grade, Then now this would be done 1050, Joanne 11.550, and so on and so forth. So this can also be opened with Excel or any spreadsheet software, but it can be opened with any spreadsheet software. And then instead now of having commas, you'd have like the lines separating each column. So now I am reading this file using Pandas special method called readCSV. So pd.readCSV essentially just opens up this CSV file, and then it changes it into the Pandas data frame that we were talking about. So let's see how a Pandas data frame looks like. So as you can see, it essentially looks like a spreadsheet. Or if you worked with Excel before, you know this is how your data would look like if you typed it in Excel. And it's also how it looked like when I showed you on that Microsoft Learn website a few minutes ago. So this is how your data looks like. At least now you can visualize what a two-dimensional array looks like. So like we have rows, and you can see it also gave us zero-based indices as well, starting from done. So the first, this will, you can call it a row, yes, but it's like a title row. So it doesn't contain our data, it just contains the title of the columns. And then now this is your data with the rows. As you can see now, it's zero-based indexed again. So this is not 1 but 0, and then 1 2 3 4 5 all the way up to down here. Yeah. So note that in addition to the columns you specified, the data frame also includes the index to uniquely identify each row or each instance. So again, I remember when I was small, I used to confuse this. Rows are like going vertically. So this is one row, 0, done, 10, 50. That's one row. 1, Joanne, 11.5, 50.0. That's another row. Then now columns are the ones which are going vertically. So rows are horizontal. Name and, am I getting this right? Which is horizontal and which is vertical? Yeah, so column is going, it's perpendicular, it's going from down to up or up to down. And then rows are like from left to right or right to left. Yeah, so finding and filtering data in a data frame. So now we're going to learn how to filter data, how to get, let's say, a specific value that you're looking for or a specific set of values that you're looking for in a data set. Let me just admit a few more people. Okay. Yeah. So how are we essentially filtering data in a data frame? How are we going to get a specific set of values that you're looking for? So you can use the data frame's lock method. So Pandas has a lock method, which I am guessing is short for locate or location, because it helps you locate things and it's called lock. So you can use the data frame's lock method with a single pair of square brackets. So just like how we were indexing lists, but now we have to use the lock method first to retrieve data for a specific index value. So when you're filtering, it's just like when you're working with lists and you're slicing. But now instead of slicing, you're filtering. And even as you'll see here, the same techniques apply. It's just slightly more advanced. So here we have df students.look 5. So what this is going to do, it's going to get the data for the 5th index or the row or the 5th row, something. Yeah. So let's run and see. So it gets that if you come here and look at 5, the name of student 5 is Vicky and studies for 1 hour. Oh my. And only gets 3 because she studies 1 hour a week. Don't study 1 hour a week. But anyway, we can confirm this now. We see that the name is indeed Vicky. she studies only for 1 hour and her grade is 3%. And we see that it doesn't come in this format that we are used to. Instead, it comes like this now vertically, and this is what we call a pandas series. So this is a pandas data frame, the one that looks like a spreadsheet, and then a pandas series is just a vertical sort of vector, like a vertical series of information, Wiki 1.0, 3.0. And so essentially a collection of series is what forms a data frame. However, if you wanted it to come as a data frame, then, okay, as I was saying, first of all, this returns a pandas series as opposed to a pandas data frame. And we can confirm by running the type of is students.look. So we see that it's pandas.core series.series. So essentially it's just a pandas series. So to retrieve the data at the fifth, sorry, this is not supposed to be index or position. Because when we are looking at look, it looks at not, okay, it's still the fifth index, yes, but when we're working with look, it looks at the labels. So these indexes are acting as labels. And so the fifth row is labeled. And it's not even the fifth, it's the sixth because there's zero-based indexing. So if you count from here, 1, 2, 3, 4, 5, 6, see that it's the sixth row, but it's just 5 because of indexing. That's why I'm saying it's not even the fifth index. Okay, it's the fifth index, yes, which is the fifth label, but it's the sixth row. So I hope that clarifies things. So to retrieve the data at the fifth index, which is the sixth row, as a data frame instead, or as opposed to a pandas series, we can use 2 pair of square brackets in our command. So now it's just the same command, df students.look, but then now inside our square brackets, instead of just having 5, yes, we still have the 5 in square brackets, and then we also have a colon here. So essentially this is, remember data comes in the form of row, comma, column, row, comma, columns. So we're saying we want the fifth row, but in the fifth row, bring all columns. That's why we have this semicolons that don't have anything before or after. So again, if you've worked with lists, you know how slicing works. And if you were to just index something and put a colon without anything before or after, it will just bring everything. So essentially that's what you're saying here. We just want the fifth row, but bring it with all the columns that it has. So let's run it to see how it will look like. So we now get it as a pandas data frame because it's in that spreadsheet format, and it is the fifth index and or the fifth row, and it has all the columns, name, study hours, and grade. So now this one comes from left to right, whereas this one was coming from up to down, name, study hours, and grade. Okay. So let's continue. So note that the general syntax is df, which is data frame, dot look, and then now row column, right? As I was saying here, this is now just specifying the rows that you want. I said I only want the fifth row, and then the column, I said I want all columns. That's why I used a colon. So you might ask, because we got the data in both formats, we got it as a pandas series and as a pandas data frame. So you might ask, what is the difference between a pandas data frame and a pandas series? So a pandas data frame is a two-dimensional labeled data structure with columns of potentially different types. So a pandas data frame, you can have columns of different types. And you can just think of it as a spreadsheet, as I said earlier, or an SQL table. So again, if you've worked with SQL or structured query language, Other people call it SQL. Depends on who told you first. But if you worked with SQL or SQL, you know it's usually just a tabular format like this as well. So in general, it is the most common used pandas object or pandas data type. Series, on the other hand, is a one-dimensional array. So already we are seeing one difference. A data frame is a two-dimensional array. A series is a one-dimensional array. And you know what arrays are because we've looked at NumPy first. Array-like object containing a sequence of values similar to a NumPy array, as I said, and an associated array of data labels. So a Panda series, on the other hand, has two arrays. So the labels, which is one, and the values, which is another one. And all of them are one-dimensional arrays. A series is a single column of a data frame. Yeah, so a series is a single column of a data frame, and a collection of series is what forms now a data frame. So I hope now you know the difference between the two, and that gets things out of the way. Sorry, I just keep pausing because I'm admitting people while we are moving forward. So we can also use the single pair of square brackets again with the lock method and slicing techniques to get a range of values. So remember here we were just getting one row. We're just getting one row. Now, how can we get a range of values? So when we write df students, which is our data frame, dot look 0 through 5. So again, remember, this is slicing, but for a pandas data frame now, we are essentially saying that we want our result to contain the row from row 0 to row 5. So let's see how that will look. So now we get a pandas data frame with the indices that we were looking from row 0 to row 5. So in addition to being able to use the lock method to find rows based on your index, you can also use something called the iloc method to find rows based on the ordinal position in the first data frame, regardless of the index. So as you can see, the first one was just look, and this one is iloc. So how I like to think about it is look just looks at the labels, which now in this case coincide with the indices, but you can also, when you're forming your data frame, you can also specify that instead of having indices from 0, 1, 2, 3, you want them from A, B, C, D. So now loc would use A as opposed to 0 and B as opposed to 1. However, when you're using iloc, it strictly uses numbers. So now it would be like indices, just indices. So I usually picture the I in iloc to be index or indices. So this one now, it now just looks at the index by itself instead of the label. I hope that is clear, but we'll see better examples as we move on forward. So for example, here we have again the same data frame, but now we're using .iloc and then still getting the same range of values. But now these are indices and not the labels. Here they coincide, yes, so they look the same, but we are going to notice a difference. So here we're being told, look carefully at the iloc, which is this one, and compare it to loc, which was this one. So if we look at both of these results, if you look at this one, and if you look at this one, there is going to be a small difference. And they're even asking, can you spot the difference? So the difference is, if you can see, this one goes 0, 1, 2, 3, 4, 5. However, this one goes 0, 1, 2, 3, 4. Doesn't get to 5. Why though? So the loc method returns rows with index label, as I said, in the list of values from 0 to 5, which includes 0, 1, 2, 3, 4, 5, which are 6 rows. However, the iloc returns the rows in the positions, which are usually what we now call indexes, in the range of 0 to 5. Since integer ranges don't include the upper bound, which is like 5, this includes only 0 to 4. So what they're essentially saying here is loc is using the labels. So it's looking at what is 0 all the way to what is labeled 5. However, iloc is looking at the positions or the indices. So again, it's going to look at from index 0 to index 5. But if you remember, again, from lists, when you're slicing a list, the last value here is usually not included, right? It's not, yeah, it's not inclusive. So when we say 0 to 5, it will bring you indices up to 4 and not up to 5. 5 is usually like your bound or your limit, so it doesn't get to 5. That's why in this case you're getting to 4. And so that's the subtle difference between loc and iloc. And as you can see, they're mostly similar. You can use them interchangeably, or you can use one for the other depending on your preference or the situation at hand. Because as I said, if you're dealing now with a larger data set, and then you find that the labels are not 0, 1, 2, 3, 4, but let's say the labels are IDs. So an ID is like a random generated number, right? But it's unique to everybody. So now in that case, in order to get a certain row, you'd have to type in the ID of a person. So you'd have to use loc. But then if the dataset is large and you can't access everybody's ID, then using iloc would be much more efficient. So they're both the same, almost the same, they look the same, but the situation at hand might require you to use one over the other. So again, as we said, iloc identifies data values in a data frame by position. And this is also true for the columns as well. So again, remember now whenever we're including a column in the iloc, we are not only now calling for just rows, but rows and columns as well. We're filtering both the rows and columns. So in this case, we're saying locate the 0th row, which is like the very first row. And then the columns, I want 2 columns, which is column 1 and column 2. So again, it brings a pandas data series, but then we find that the 0th row, the column 1 is study hours and column 2 is grade, and the 0th row contains 10 and 50. So we can confirm from this data frame here, this is the 0th row or the first row, and we only wanted, so this is column, this will be column 0, column 1, column 2 again, because we're using iloc, which is index based. So this is going to be the 0th row, which is the first row, and we're just expecting to get 10 and 50 because we've only filtered column 1 and column 2. So as you can compare with the code again, the 0th row, column 1 and column 2, we're only expecting study hours to be 10 and grade to be 50. And that's what we get here, study hours to be 10, grade to be 50. And again, this returns a pandas series. To return a pandas data frame, maybe so that you can visualize it better, we also surround 0 with square brackets. So instead of just having it open like this, you surround it with square brackets. This time it's going to return a pandas data frame. Again, the same thing, we're saying we want the 0th row or the first row, and then the column 1 and 2, but with regards to 0-based indexing, get the same thing, 10, 50, which was here. So as you can see, we've just filtered our data to get this section. And our data was even larger than this. I recall it having, I don't know, close to 24 rows. It's still a small data set, but for the purpose of learning, it had to be small. Yeah. So let's return to the loc method and see how it works with columns. So here now we were using iloc to filter both rows and columns. So how can we use loc to filter both rows and columns? So remember, iloc uses the indexes. Loc is going to use now the labels. So remember now the labels of the rows were coinciding with the indexes, so it was 0, 1, 2. But the labels of the columns, as you can see, it's not now numbers, it's like strings, study hours and grade. So these are now the labels. And so if we wanted to obtain the same set of data, we'd now write loc, and then the row, we include the row label, which was 0, coinciding with the row index, and then the column labels that we wanted. So now instead of 1, 2, we write study hours and grade. So when we run this, we get what we got here. And then again, if you want to change it into a pandas data frame, you just surround the 0 with another set of square brackets, and we get the same thing. So as you can see, loc and iloc work in a pretty similar fashion, but we saw the difference is one is using indices and the other one is using labels. So I hope that clarifies the difference between loc and iloc. Let me just get more people. And also beams on the chart. Okay, I'm using VS Code, and VS Code has an extension. So thank you for answering that, John. Thank you so much for answering that. Let's continue. If you have any more questions, just keep on posting them in the chat. Hopefully someone will answer them. I can't see the chat while I'm also looking at the screen I'm sharing, but I'll be glancing at it from time to time. So moving forward, here's another useful trick. You can use the loc method to find index-based rows based on a filtering expression that references named columns other than the index, like this. So when you write df.loc, so instead of just saying row and column as we've been doing, let's say we want a specific value, we want Aisha, for example. So we can use a Boolean expression. Again, that's why it was great if you at least had the basics of Python. So a Boolean is essentially an expression that returns true or false. You can use a Boolean expression and say, we just want to locate where the data frame of students with the label name is Aisha. And when I run this, it's just going to return only where there is Aisha. It's only going to return that row. So we can, for example, investigate, if we wanted to investigate just one student, how long does the student study and what did the student get at the end of the semester. In this case, Aisha studied 12 hours and she scored a whopping 64, as opposed to the other student who studied for, was it just 1 hour a week and ended up scoring 3. So actually, you don't even need to explicitly use the loc method in this case. You can just simply like remove that part and it would work the same way. So if we run that, still brings the same result. And another way you can also do the same thing is by typing df students, and there's a query method. So this is a method that is again specific to pandas objects or panda data frames. And when you run query, again with the boolean name is Aisha, when we run this again, we get the same thing. So the reason I was showing all this is to show you how the 3 previous examples underline a confusing truth about working with pandas. So often there are multiple ways to achieve the same results, and this can be really confusing, especially if you're just venturing into it. You see that one way you can use loc, you can use iloc, you can now query. You don't even need to add the loc method at the end. So this can be confusing at first, but for me, what I usually do is I just stick to one thing. So if I decide I'll be using loc, that's what I'll be using, and that's like it. So instead of just trying to master everything, I just stick to one thing or one paradigm. So often there are multiple ways to achieve the same results. And again, there's another example of achieving these results that we've been doing here. And that is, instead of putting name in square brackets as a label, you can now just put .name as an attribute instead. Again, still gives us the same results. So it's just a confusing truth that there are many ways of achieving the same results. So it might be difficult when you're collaborating with someone and they do something different. So don't get confused. Just know, especially when it comes to pandas, there are many ways of solving the same problems. So I don't know if you noticed while we started earlier and I showed you this very small data frame that we have, that there were some values that were missing. So, okay, it's here. So this is the whole data frame that we are working with. And as we scroll down, we see that we have, yes, our labels, the names of our students, the study hours, and the grades. But as we continue investigating our data, we find that Bill, for example, did not submit what they got at the end. And Ted didn't even tell us how long he studies and what he got at the end. So we end up with missing values. So the question becomes, how do we deal with these missing values? Because at the end of the day, we need to run computations along the whole data set. And these missing values are going to give us errors, give us problems, or give us wrong insights. So how are we going to deal with missing values? So there are a couple of ways of dealing with missing values that we're going to look at today. So this is one, handling missing values. So one of the most common issues data scientists need to deal with is incomplete or missing data. So even when you're doing a research project, go out to collect data, sometimes you send out forms, online forms even, and people decide they're filling the part they want and the part that they don't want. You also forgot to put it to be mandatory or something like that. Or you handed out like physical paper questionnaires and people returned it filling what the fields they want and leaving the parts they didn't want, so, or they didn't understand for that matter. So you're going to end up with missing values in many cases. So how will we know the data frame contains missing values in the first place? So other than just inspecting like we did, if you are working with a large data frame, it's not even going to display fully. So how are we going to know that there are missing values in our data frame? So we have a method called isNull, which is used to identify whether our data frame has missing values. So it's just data frame dot isNull. This is how our normal method looks like. When we run it, it returns false for the places that are not null, and the places that are null or missing, it returns true. So again, as I said, with larger data frame, it would be inefficient to review all the rows individually like we've just done right now. So we can get the sum of missing values instead of just trying to investigate row by row, whether these are true or false. You just add sum, and then it tells you with each column how many missing values are there. So we see that there are no missing values in the name column, which is true. We already saw it prior. And then there's one who's missing study hours. And then grade, we have two missing values. So again, we can confirm with the CSV file that I showed you earlier. We have name and it goes all the way to 25, but recall that the first one was the title rows, so it doesn't count. So this is actually our first thing. So we see that there are no missing values here. And then when it comes to study hours, which is now blue, we see that we have one missing value from Ted. And then grade, which is now yellow, we have two missing values from Ted again and from Bill. And that just confirms this Pandas series that we've gotten from running the sum and the isNull method. So moving forward, now we know that there's one missing study hours, that was Ted, and two missing grades, that was Ted and Bill again. So to see them in context, we can filter the data frame to include only the rows where any of the columns, remember now columns are axis 1, and then rows are usually axis 0, are null. So essentially we just want to filter where we are getting true here. So where we have missing values. And remember here when we were filtering Aisha, essentially we were just creating a Boolean inside here. We're just creating a Boolean inside here and then now printing the row where this Boolean is true. And the only place it was true was when name was Aisha. So now we're going to do the same thing, but instead we're going to do it where we have a missing value or where is null is true. So again, dear students, then this brings us is true, but then we have to check with regards to the axis 1, which is now telling it look at the columns. So we get this data frame. Again, it was Bill and Ted who had missing values. Ted was missing both study hours and grade, and Bill was just missing the grade. So essentially the columns which we were looking for, study hours has only one missing value, whereas grade has two missing values, and we've seen the students in context. So we're almost getting to the end of the session. I remember the session was supposed to end at 9, and the workshop is almost ending as well. So the data frame is retrieved and the missing numeric values show up as NaN or none, which means not a number. So it's just blank. So now that we found the null values, what can we do about them? So how do we deal with null values or missing values? So one common approach is to impute replacement values, and what people usually do to replace these values, or the most common method that I know, is just using a method of central tendency such as a mean or the average. So you get the average, let's say, of study hours. What is the average study hours? And we already saw that it was 10.5 something. So in this case, we'd feel that Ted studied for 10.5 if Ted is an average student, which we are assuming. And then now for grade, again, we get the average, and we saw the average was 49 point something. And then we'd feel that for both of them, 49, 49. So that's one method of doing it, filling it with the average. So if the study hours is missing, we could just assume that the student studied for an average amount of time and replace the missing values with the mean study hours. To do this, we have the fill now method. So we have, this is like creating a new or a subset of a data frame, and then checking if the study hours has null, which we already did, and now we're filling it, and we're filling it with what value? The mean of the study hours. So we're getting the mean of the study hours, and then we're filling it using the fill now method. Now when we run it, we see now that the study hours has no null value. We see that Ted has the values for the study hours. Initially, he didn't have. And if you can remember, the average was 10 point something. So that's it. And then now we can fill in again the grades with an average value. But then, as you can see, that is based on assumption, right? You're just assuming somebody studied for the average amount of hours, which might not be the case. So alternatively, another method that is usually used is just dropping or deleting the rows that have missing values. So if you have rows that have missing values, you just chuck them. In this case, they're not many, it's just 2 rows, Bill and Ted. They won't affect our overall insights as much. So in this case, you can drop the rows or columns containing null values by using the drop now method. So the first time we used the fill now we're using the drop now method. For example, we'll remove rows. So remember, again, as I told you, rows are usually identified by axis 0 and then columns axis 1, where any of the columns contains null values. So now the same thing again, but now we're not even filtering the label like study hours or study hours, because we're now just looking at the data frame as a whole, looking for any null value. And if there's any null value, we're dropping the whole row. That's why we have axis 0. If axis was 1, you'd drop the whole column instead where there's a null value. So let's run this. And now we see our data does not have Bill and Ted. It ends at 21 with Aisha. So Bill and Ted have been dropped because they have null values. So now we have like a complete data set, so to speak. We can use this data set to now come up with visualizations and gain insights from the visualizations. So up to that point, I hope not much questions. Let me just see the chat. Mind sharing the GitHub link to the repo containing the grades.ipynb. So it's not on GitHub yet, but I will upload it to GitHub at the end of the session, and yeah, I'll share the link. So I'll just share it in the chat here. I might also follow up with an email. You can also drop the non values using correct. Thank you for that, Sarah. So we've also seen that. And there's an additional method that I can add, but this one you can now go and study on your own. So I take statistics classes, and in one of the classes called numeric methods, we learned another way of dealing with null values, which is interpolation. So essentially you'd come up with formulas or functions that interpolate the data, in that it tries to estimate what that data would be based on the other values that are surrounding it. So you can go look at that, just probably search numeric methods, interpolation techniques, or interpolation functions. Yeah, and then learn about that if you're really into the quantitative side. So I'm seeing Elizabeth has her hand up. I don't know if she has a question or a comment. If so, go ahead.
Yes, I have a question. When you have like a larger data set and you have those null values, is there like a way, maybe like a percentage for you to know when to impute or when to drop the null values?
So you're like essentially asking whether there's a criteria for you to decide whether you're going to impute it with a mean or you're going to decide to drop them. So I'm not sure if there is a standard percent. Maybe I'll look into that. However, I'd just say mostly it depends on your data set as well, because sometimes you might be handling very sensitive data that should really have very, very little room for error. So for example, if it is a data set where you want to predict the possibility of having a heart attack for patients, in such a case, I'd say it is better not to estimate with means, but to just drop null values. But again, if the null values are so many, that will largely affect your data. So I'm seeing there's a comment here again. If null values are lower than 5%, you can drop them, since that won't have much impact on your analysis. Okay, yeah. Again, this 5% coincides to a certain thing I also learned in class, whereby we usually say that there's something called usual values and unusual values. So unusual values, as the name suggests, are those which are unlikely to happen, and usual are those which are most likely to happen. And so in your data set, 95% of the values are usual values, and then 5% are unusual values. So as Alan says here, if it's lower than 5%, you can also drop it, because two standard deviations within the mean usually occur within 95%. So thank you for that, Alan, as well. It makes sense, actually, now that I think about it. Could you kindly share the recording? Oh, yeah, the recording will be shared. I'll share a link to the recording. Yeah. Okay, I think we can continue from there. I'm seeing we only have 10 minutes. We might extend by a bit. I hope you don't mind. Sorry for that. So explore data in the data frame. So, okay, we'll just have to go through this quickly. Again, now we're exploring this data, but with regards to a data frame, the first time we were using NumPy, we got the mean and the for both the grade and the study hours. You can do that again using the F string, so that's no issue. And then now we can filter the data frame to just get students who studied more than the average amount. So remember, the average amount that people are studying was 10.5 something hours. So now we just want students who studied for more than 10.5 hours and look at their grades. So these are people who got studied for more than 10.5 hours. And as you can see, they scored really high grades. Their grades were also above average. There's no one here who got 49 point, what was the average grade? 49.1 or below. Everyone scored above average because they were studying above average. So as you can see here, there is a correlation between the amount of study hours and the grade that you get at the end of the semester. So for example, we see Rosie studied for 16 hours and she got 97%, as opposed to the first person, Vicky, her name was Vicky, who studied for only 1 hour per week and got 3%. So there is a high correlation between study hours and the grade that you get. So note that the filtered results is itself a data frame. So yeah, this is a data frame. And you can work with its columns just like any other data frame. Yeah. And then again, something else I also wanted to show you. Now look at the result here. We see 1, 3, 6, 9, 10, 11, 14, 19. So these are not in order. We see there are some that are being skipped, showing us that the numbers that we see here were not just indices, but labels. And now, since we filtered out some rows, it would have changed, and now this would have been 0, 1, 2, 3, if that was the case, but it hasn't changed. The numbers still remains 1, 3. So Aisha was number 21 in our original data set, and now in the filtered data set, she's still 21. So as you can see here, 21, 21. So these were labels and not indices. It's just that when we were looking at it from this perspective, then the labels and the indices were coinciding. But now that we filtered them, we see that this is index 0, yes, but the label is 1. So again, as we said, we can use, we can work with the loc just as we were doing, but now for this. But then now you would have to be careful, because now when you're using loc, you'll be working with the labels. But then when you're using iloc, you'd be working with the indexes or the position or of the rows. So I hope that further clarifies the difference between loc and iloc. So again, we can also find the average by just using the dot mean. So remember, the dot mean was a NumPy method, but Pandas is built on top of NumPy, so it will also work here as well. Because these are essentially just arrays, a collection of arrays, making it a data frame. So again, we see that when we're getting the mean grade, it's now 66.7, but then this is the mean grade of the people who studied above average. So we see that if you studied for more than, for more than 10 hours per week, then you're likely to fall within the people whose mean grade was 66.7. So assuming that the passing grade for the course is 60, that is, if you get above 60, you passed. If you got below 60, you failed, you have to redo the course. We can use this information to add a new column to the data frame that indicates whether or not each student passed. So first, we'll create a Pandas series. Remember, we clarify the difference between a series and a data frame, so that a series is just like a one-dimensional array, and then now a data frame is just like a collection of series. So data frame is a two-dimensional array in that case. So first we create a series containing the pass or fail indicator, and then we'll concatenate that series into the data frame. So concatenating is just like putting it together or sticking it together. If you can remember, or if you were there while you were starting the session, you can remember how the lists were concatenating when we were multiplying them by a number. So in this case, we are going to concatenate the Panda series that we create to create a new row to see whether somebody passed or failed, and then we can look at how long they studied to see whether they pass or fail. So this is the Pandas series that we create, so essentially we're just filtering the data where the student where the grade of the student is greater than or equal to 60. So once we get the Pandas series with these Boolean values, we're going to concatenate it or just smoosh it or just stick it, like add it into our data frame. So let's run this to see what we'll get. You see now this is the new column that we've added. So it's just looking, is grade greater than or equal to 60? In this case, it's not. So it says false. Again, is it greater than or equal to 60? No, it's not, false. But then when it gets one that is greater than or equal to 60, it says true. So for the people who are getting true, these are the people who passed the class. And then the people who are getting false, like poor Vicky here, these are the people who failed the class. So data frames are designed for tabular data, as we've been seeing throughout, and you can use them to perform many kinds of data analytics operations you can do in a relational database, so such as grouping, aggregating. So a relational database is like the SQL I was talking about, just relating tables to each other. And we're being told that most of the operations you can do in a relational database, you can also do here using Pandas data frame. So for example, you can use the group by method to group the students' data into groups based on the pass columns you previously added to count the names of each group. In other words, you can determine how many students passed and how many failed. So essentially, we're going to print the data frame that we have of students, but we're now going to group it by students who passed, and then we're going to count. So let's see what this returns. Since we are counting, it returns a count where false is 15. So that means 15 students failed, and then true is 7. So 7 students passed. And it would be safe to assume that all these 7 students studied above the average study hours of 10. So the hypothesis was true. If you are actually doing testing hypothesis class, then you'd actually say that we accept the null hypothesis, which is it is true that when you study for a certain period of time, then you're more likely to pass the exam. So you can aggregate multiple fields in a group using any available aggregation function. So essentially, this is just saying how we can carry out aggregates. Like this is a mean. So the average study hours of the people who failed was like 8 and below, and the average grade was 38. And then the ones who passed was 14 and above, and the average grade is 73. So the ones who passed are the ones who got above 60. So yeah, we are winding up with the data frame, but I also promised to do some data visualization. Luckily, that's not too long as the Pandas data frame was. So let's just finish up. Their data frames are amazingly versatile and easy to manipulate. For example, the following code sorts students' data into descending order. So it's just, again, how you would group them. In this case, this is grouping by grade. I'll just share this in a GitHub. I'll share the GitHub repo to this once I upload it to GitHub. So again, it arranges it now according to grade. So from the highest to the lowest. And we can now use this to compare with the study hours. We see that the person who had the highest grade coincidentally also had the highest study hours. So it's not actually coincidence, there's a correlation between that. So NumPy and Pandas are the workhorses of data science in Python. They provide us a way to explore and analyze tabular data. So now we're going to learn how to visualize data. Let me just see if there's any more comments in the chat before I continue. Could you kindly repeat what you said about instances recommended to use iloc and loc? Okay, let me see if I can remember it. But I said like iloc and loc, they might look the same and work the same, but they have differences in that loc filters data based on their labels, whereas iloc filters data based on their indexes. So when you have a large data set, and let's say now, instead of that data set having labels that are indices like this one you see here 0 1 2 3 4 5 6, let's say now the labels were like ID numbers, for example, so people's ID numbers or these students ID numbers or registration numbers for that matter. So again, it'd still be unique identifiers, but if you wanted now to filter to, let's say, get Vicky, you'd have to know Vicky's registration number offered or maybe written on a piece of paper somewhere or something like that. Or maybe Vicky came with her ID card, I don't know. But then now you'd have to type loc and then you have to locate that registration number. But then when you're using iloc, iloc now uses based on the position of the person. So in this case, Vicky is index 5. Accounting for zero-based indexing. So in that case, now you'd use 5 instead of the label. So which would be the registration number. So it just depends on the situation that you're handling at that point in time and the amount of information that you have. So if you're looking for a specific set of value, do you know like the label of that row or do you know the index? So if you know the index, you use the iloc. If you know the label, you use the loc. If you know neither, you can locate it also by using the Boolean or the query that I showed you earlier. So that was way above. Yeah, you can also use the query method. So now this will just, let's say you are looking for Aisha, but you didn't know both her index or her ID. So in this case, you just use the query method. Again, I showed you there are many different ways of achieving the same result. So it's up to you to choose the method that you're going to conform to. Let me just go back to where I was before I continue looking at the chart. I hope that answers your question. The session is who. I just wanted to ask if this class will be there next time and when. This is my first time here. So I'm glad you're enjoying it. This was just an impromptu thing I decided to put up. I do not know whether, I'm not sure yet whether I want it to be a series or not. I'll deliberate about that depending on my schedule because I'm also a student among many other things. So I would also like it to be a series. So whenever I get time, I'll be doing this. Let me say that. Whenever I get time, I'll be doing this. Okay, you're welcome, Fatma. So I guess we can continue into the data visualization part. All right. So in this section, we'll apply a few techniques to analyze data, basic statistics. So it's just data visualization. We're going to visualize with a package called Matplotlib. I don't know if this is a package or a library because it's a collection, but we've already looked at a package called NumPy. We've looked at one called Pandas. So now how can we visualize this data? Because usually as a data analyst or a data scientist, yes, you understand all the stats, you understand all the numbers, you know how to code, but then your audience or the people you'll be sharing this with, because remember, at the end of the day, you're analyzing data to get insights, and you're going to be sharing these insights with stakeholders who might not be as tech savvy or math savvy as you are. So how can you explain it in a simple way, but it is still comprehensive in that it captures all the details of the insights? So this is where data visualization comes in. You visualize data in, it's like summarizing data in a picture, in short, that is easy to understand. So data frames provide a great way to explore and analyze tabular data, as we have done, but sometimes a picture is worth 1,000 rows and columns. So you might be working with a large data set with even, I don't know, 500K rows, but then you can summarize it into one figure, into one picture using Matplotlib. So it's a library, yeah, not a package, because it's like a collection of packages. And it provides the foundation for plotting data visualizations that can greatly enhance your ability to analyze data. So we're not going to do a lot here. We're just going to come up with bar plots and a pie chart, and then we'll call it a day for today, or a night, depending on where you're watching this from. So anyway, let's start with a simple bar chart that shows the grade of each student. So again, as we started with NumPy, you have to import it first. And you can't import it if it's not in your system. So if you haven't downloaded Matplotlib before, first be sure to download Matplotlib by running the command pip install Matplotlib. Then once it installs, you can import it. But then here, unlike, I don't know if you remembered, for pandas and NumPy, we were just saying import pandas as PD, import NumPy as NP. But here we're saying from Matplotlib, so we have a from first. And the reason for this is we're importing the package, which is pyplot, but it is contained in a library called Matplotlib. So a library is a collection of packages. So remember, NumPy and Pandas, it was just a package, so we just needed this section of the import statement. But since this is a whole library, we start from the library, now import the package that I want, which is pyplot, and then just use plt, because I don't want to go ahead and be typing matplotlib.pyplot and then .method all over. Plt is a very short alias that I can use instead of repeating matplotlib.pyplot all over. So now we are going to create a bar plot. If you don't know what a bar plot is, you're going to see it once I run this code, where we are just going to visualize the name of each person and the grade they got. So Matplotlib works like this, or pyplot in this case. You first plot it, and then now you have to show it. So think of this .show like your print statement whenever you come up with a variable and then you want to print it. So this is like a print statement, but for graphs or for data visualization. So, okay, this is going to take a while for the first plot, but then after that, okay, it's going to get better. So as you can see, we are seeing the grades of each student. Again, it has come in order from the highest to the lowest, but you can't even read the name of the students because they're like smooched up together, they're squeezed. So we can't even read the name of each student. And the good thing about Matplotlib is we can now customize our graph in the sense that it is beautiful and yet it is also easy to understand. So yes, here we can see the marks ranging from 0 to 100, but we can't see clearly who got what. The plots are just squeezed together. We can't even see the names. We don't even know whether these are names. We don't know what this is. Are they marks? Are they percentages? Are they grades? What is this 0 to 100? Is it the study time? So let's see how we can customize it so that we make this graph more understandable. So that worked, yes, but the chart could use some improvements, as I've said. So note that we've used the pyplot class from Matplotlib to plot the chart. This class provides many ways to improve the visual elements of the plot. So for example, now this following code that is here, first of all, specifies the color of the bar chart. So now we want to change the color of this bar chart, so it defaulted to blue. But now when we write plot.bar, first of all, now you're going to see that we are including many more arguments than here. So in the beginning, we just said let your x-axis, which is the one that is down here, be the name. So our dataframe.name, let it be the name column. And then the height, let it be on the y-axis, let it be the grade. So it picked from 0 to 100. But then now we've added another argument, which is color, and we've put orange. So, just to make it better, or just to show you that you can change the color of your plot as well, depending, let's say if you're working in a company and the theme of that company was orange, so you can also just change it to match the theme of that company as well. So the code also adds the title to the chart, so we know what it represents. So, and I usually advise that this should be the first thing that you do. Write your title first in any graph. So essentially, if you come from a math background where you're drawing graphs, you usually want to label it. So in the same case here, when you're plotting it on Matplotlib, you want to write plt.title and then just give your graph a title. And then we also add the labels to the X and Y axis. So remember here, you don't know what this is. Are these the grades? Are these the total study hours? What are these? We can't even read in the first place. So in this case, now we're titling the X axis, which is the horizontal one, to be student. And then the y-axis, we are titling it to be the grade. So now we are going to be able to tell that, yes, this is the grade, and these are the names of the student, and the title of this is student grades, which is going to show up on top here. So we're also going to add grids to just be able to easier determine who got what. Yeah, because essentially if you look at this, you can't tell where this is. You just see it's like between 20 and 50, 40 or whatever. At least now you'll be able to see it's like right there in the middle or not. And these are just the specification of the grid lines. It's going to be whatever this color is. So you can also add colors. Instead of just writing the name, you can use a color code as well. The style of the line and whatnot and whatnot. So let me just print this and then you're going to see what this does. So now look at this. It's way better than one before. So as I said, it changes the color to orange. That was the first thing. Second, we've added a title to our graph now, right? And then we've added a label for our x-axis and our y-axis. So for our x-axis, we know that these are grades now from 0 to 100. And then now we know that these are students. And then, so this is the grid line that we've also added. These are the grid lines that we've added. We can see that there are 2 students who scored above 80, and then a couple more that scored above 60. And these are the students that we are interested in, from Rajab going to Rosie, the ones who scored 60 and above. These are the people who passed. And then the X ticks, we've rotated them to 90. So X ticks, these are the ticks here. These are the ticks. Again, this is a tick. So this would be the Y ticks. And then these are the X ticks. So initially they were all smudged up in the sense that they were overlaying on each other and it became illegible. We couldn't read and we don't know who got what. We only know that Vicky got 3. But now we are able to see everybody, right? Because we've rotated the ticks 90. So the thing about Matplotlib is that it's very customizable. You can customize it however much you want to make it as beautiful as you wish and as understandable as you wish. So last but definitely not least, we can also visualize this as a bar chart, essentially just trying to see how many students passed and how many students failed. So you can remember this code also from the top, where we were now looking at the people who passed and the people who failed, and it came as a Boolean where the people who passed were true and then the people who failed were false. So now we are just going to count the values of the people who passed. And then we are going to plot a pie chart where we're going to have pass counts, the people who passed, and the people who failed are now going to be the rest, right? So let's plot this and see how it's going to look like. So this is our pie chart. We see and confirm that it is 7 people who passed, as we noted earlier. When we only filtered the people who got above 70, above 60, it was only 7 people. And then now the people who failed are represented by the false, which was blue, and is 15. So that brings us to the end. I hope you enjoyed the session. Let me now just look at the chat. If you have any questions or comments, now would be the best time to do so. Let me now start looking at the chart, especially leading to AI models. Thanks a lot. So I'm also learning just like you people are. So when I learn about creating models, then I'll be sure to share. Whenever I learn something, I'll be sure to share. You're welcome. How do we add color to the title student grades? Oh, okay. So essentially you're asking how we add color to this title here. So I'm not sure whether you can add colors to titles. I'll have to look at the documentation, or I can also share the documentation with your emails. So I hope you registered by filling a form and you've been getting email updates of these events. That's how I intend to be communicating. So I'll share the resources, which is, by the way, I have to upload these to GitHub. So let me just do that right now. So I'll share this GitHub there. I'll also share the recording and the Microsoft Learn module that I've used to generate this content. So by the way, I'd encourage you to look at that Microsoft Learn module because it looks at the NumPys and Pandas and data visualization a little bit more in depth. For this, I just filtered the basic data. Not basic data, but basic information. Just assuming that most of the people would were not familiar with NumPy and Pandas. So you're all very welcome. I don't know whether I'll have another session, but I'll try my best whenever I get time. All right. Thank you so much for the positive feedback. Is there anybody else speaking?
Yeah, Ken. So I have a question. I know you are an MLSA, and for the new cohort, it's not exactly the same way you guys were doing it, and I have had some navigation issues as I tried to connect to Discord and the LinkedIn roles and some challenges. Could I side chat you so that you could kind of help me navigate?
Yeah, sure. Do you have my number?
Well, I'm in UCC and so are you, so I'll just get your number there.
Okay, fine. Yeah.
Okay.
Feel free to side chat me as well.
Okay, thanks.
You're welcome. So someone says, nice presentation. You have challenged me to learn R. Good for you. I don't know whether I'll be venturing to R anytime soon. I have a bias for Python because that's what I started learning with, and it was and still is enjoyable, so I'll stick to that. And then you go ahead to ask, how do we get the LinkedIn subscription? So I did say that you stand a chance to win a LinkedIn subscription, which is a 6 months LinkedIn voucher. So for 6 months, you'd have free or premium LinkedIn. But essentially, I am not going to get like LinkedIn vouchers for every single attendee. I'm only going to get a few LinkedIn vouchers, and I'm going to essentially distribute them randomly. Yeah, so you can do the statistics or probability of you getting, as opposed to how many people were we in the chat. I don't know. I saw there was a point where we were like 50 or something. So it's like a 10% chance. Yeah. How can we access the recordings? I'll share a link. I hope you registered via the form. If you did, then I have your email address where I'll share the link. So how does one join Microsoft Student? So I'm guessing you're referring to the program that Sarah has mentioned, which is the Microsoft Learn Student Ambassadors program. So I will give deprecated information because, as you've heard her say, should I call it a regime or a paradigm? Like, it has changed. The program has changed over the past few months. So how we used to do it, that was when I was joining in 2022 of October. You'd have to go to the site, which I don't know whether it's the same. Just search Microsoft Learn Student Ambassadors and then click on the first site. It will be the first site. For us, we had a button where you had to apply, and while you were applying, you had to like answer 3 essay questions and also submit a video of yourself. However, I am aware that there is a new model. I haven't really looked into it. Maybe Sarah can. I don't know if she's a Microsoft Learn Student Ambassador. If so, she can tell you how she got in, but I heard it's a registration process instead.
Yeah. So how to go about it? You just apply. You go to their website, as I also did, but then you have to now be connected to. You have to create a Discord channel. Also, you have to be in GitHub, and then they will give you some tasks. After you complete each and every task, you complete the two modules, then you are able to be either selected or not. Yeah. You just have to wait to know if you have been selected.
Okay, cool. That sounds, I hope that answers your question, Immaculate. That sounds way easier than how we used to do it. For us, we had like 3 essay questions that you had to write, and one of them you had to like answer with a video. And then you obviously type in your essay questions. 2022 was that ChatGPT? I don't think so. I think it came at the end of 2022. I did it prior, or was it even 2020? Yeah, I think it was at the end of 2022. So I joined in like October of 2022 and it came out, I think, December 2022. So there wasn't that much you could use to cook your stuff. You just have to like use your brain to write the essay questions. And then after the essay questions, you'd also have to upload a video of yourself answering one of the 3 essay questions. The video had to be less than 2 minutes, but it also had to like tell a lot about you and your commitment towards tech communities and things like that. And then once you apply, you'd have to sit and wait and hope to get selected. So they selected people once every quarter. Yeah, so for me, I applied once and got in, but I know of a few ambassadors who had to apply more than once to get in. All right, thank you so much. I don't know if there are any more questions. If not, maybe you can just end the session here. Okay, I'm assuming there are no more questions, so we can end the session here. Thank you so much for joining. Thank you so much for staying with me, even though you've gone over time. It's been 24 minutes over time, but you still sacrificed your time, so thank you so much. I'll deliberate on whether or not to have another session. But in the meantime, keep learning. Keep sending resources. Yeah. Thank you so much. Have a nice rest of the week.
Thank you, Apondi, and everyone else who joined. It has been an amazing session and great learning. So wish to meet you with another time. Bye, everyone.
Bye. You're very welcome. The recording will be shared through your emails, the ones that you use to register for the session.
All right.